Hey everyone, today we're going to be reviewing for our test that we will be having tomorrow. This is the first half of Unit 6, so it's going to cover three main topics: the Pythagorean theorem, special right triangles, and geometric mean. So we're going to need our review today and our calculator, and as always, you're allowed to use your calculator and your review on the test, so it is really in everyone's best interest to complete this whole thing. Okay, so first up was Pythagorean theorem. And there's two things that we can do with it. Well, first, we could just solve for missing sides, right? So a squared plus b squared equals c squared. But that only works when it's a right triangle. So if c squared is less than a squared plus b squared, that would be acute. And if c squared is greater, then that would be obtuse. But before you can classify those triangles, you have to decide whether the three sides they give you can even be a triangle to begin with. And this is how you decide. You add up the two shorter sides, so if a and b are the two shorter sides, you add them up, and that has to be greater than the longest side. If it's less than or if it's equal to, then it would be no. So we're going to do the example side. We're going to do the odd ones. So looking at number 1, classify each of the following as acute, obtuse, right, or not a triangle. So first thing I'm going to do is check to see if it could even make a triangle. So it's in order. The largest one is the third one. So these two smaller ones, 8 plus 10, that's 18. That's greater than 11, so yes, it is a triangle. But now we want to see what kind. So since 11 is the biggest number, 11 has to be C. So first we're going to do 11 squared, and then we're going to compare that to 8 squared plus 10 squared, and we're going to see what symbol should go right here in the middle. Okay, so I'm going to get my calculator. Go to new. 11 squared, that gives me 121. 8 squared plus 10 squared, that gives me 164. So the right side is bigger. So since that's a less than symbol, that'll make this acute. Okay, the second one, 16, 63, and 65. So again, it's in order. So these two shortest ones, if I add them together, that is for sure bigger than 65 because 63 plus 2 is already equal. So this is for sure a triangle. So we get C, so that's 65 squared, and we're going to compare it to the sum of the squares of the other two. And let's see what we end up with. 65 squared gives me that big number, 4,225. 16 squared plus 63 squared gives me the same exact thing. So since these are equal, that's going to be a right triangle. Okay, the third one, first let's check to see if it makes a triangle. 7 plus 18, that is 25. So is 25 bigger than 25? No, they're equal. So this is one of those where it doesn't even make a triangle. So I'm going to put not triangle. So the third one, since there's only one left, it's probably obtuse, but let's still check it out anyway. 10 plus 11 is 21, and 21 is for sure greater than 19. So now we're going to check to see what kind of triangle it makes. 19 squared, but we're comparing that to 10 squared plus 11 squared. Okay, 19 squared gives me 361. 10 squared plus 11 squared gives me 221. So 19 squared is bigger. So that's a greater than symbol, which means that this is obtuse. Okay. Number 3, the legs of a right triangle have lengths of 4 and 6. What is the length of the hypotenuse? And then simplify. So when it comes to the Pythagorean theorem, and I'm going to write it again right here, a squared plus b squared equals c squared, so it has to be equal. C has to be the hypotenuse. C is the hypotenuse. So that means that a and b are both legs. So the 4 and the 6 that they gave us, that's a and b. So we're just going to plug it in. 4 squared plus 6 squared equals c squared, and then let's solve for c. So this left side, I'm just going to put it in the calculator all together and let's see what we get. 4 squared plus 6 squared. That gives me 52. Okay, but I want just regular c. I don't want it to be squared, so we're going to square root both sides. If you try to do this in the calculator, so square root of 52, it's going to give you a decimal. And on your test, it's not decimal. It's going to be a simplified radical. So this is where you have to rewrite square root of 52. So I'm going to write it here on the side, square root 52. We need to break it down into all of its factors. So if you go to menu, 2 for number, 3 for factor, and then type in 52, it'll tell you what you can break it into. So 2 squared times 13 means that 52 can be written as 2 times another 2 times 13. The little 2 tells you how many times to write it. And since there's a pair of 2's, that could go on the outside. Since 13 is all alone, it stays in the inside. So the length of that hypotenuse is 2 square root of 13. That's what your answer choices are going to look like. And if you want, you could even type this into the calculator, 2 square root 13, and just double check that you get the same decimal both times. Okay, number 5. This one's kind of tricky because they want you to find perimeter of ADC. That means that we need to know the length of all 3 sides. Here's AD, so we're going to need to know that one. DC, we need to know that. And then AC. And then once we have all 3 sides, then we just add them together. Perimeter is easy. So the hard part is actually finding the length. AD, so this little piece right here, that's pretty easy to find because if all the way across is 27 and this is 15, we're going to subtract to see what's left over. So that gives me 12. Okay, so that's one side down. What about this green side right here if I wanted to find that? Well, that's part of this right triangle. That's the hypotenuse. So I could do 15 as A, 36 as B, and then this part is C. Since I don't know what it is right now, I'm just going to call it X, and then we'll solve for X. Okay, so to find that, we're going to do 15 squared plus 36 squared equals X squared. Let's figure out this left side. That gives me a big number, 1521 equals X squared. But I just want normal X. I don't want X squared. So I'm going to try it in the calculator and hopefully that'll work. If it's a whole number, that'll be perfect. And yeah, it is. It's 39. So X is 39. That's not the final answer. That's just the length of that green side. Okay, so I have 2 sides, but I still need to find this purple one, AC. So that purple one, now you would look at the outer one, is the hypotenuse of that. So we have 27 as our A, 36 as our B, and we're going to try to find that purple side. Again, since we don't know what it is, I'm just going to give it a letter, so I'm going to give it Y. So let's do 27 squared plus 36 squared equals Y squared. And then let's find out what these two give us. Okay, so that right side is 2025. And then let's square root that. And hopefully it's a whole number. Yes, it is, 45. So Y is 45. So this missing side right here. Okay, but be careful with what they're asking you to find. It says to find the perimeter of ADC. So ADC, we need to add up all 3 sides, which now we have. So perimeter is going to equal 12 plus 39 plus 45. So let's find out what that is. The perimeter of that triangle is 96. Okay, so that's what you're going to need to know for Pythagorean theorem. The other thing that we learned about was special right triangles, and there's two types. There's the 45, 45, 90, where at least one of the angles will be labeled 45. Then we have our right angle, so across is always going to be the hypotenuse. So wherever the right angle is, that is hypotenuse. The other two are just legs. And then the cool thing about 45, 45, 90 is both legs are the same. So this tells you if the leg is A, hypotenuse is A times square root of 2. So see that same formula? I wrote it in words. The hypotenuse is the leg times square root of 2. But say you were trying to go backwards. The leg is the hypotenuse divided by square root of 2. Okay, the other right triangle that we had was a 30, 60, 90. This one, all three sides are different. So wherever the 30 degree is, so the smallest angle, is always going to be across the shortest side. So A right here, that's the short side. And then we know across from the right angle is hypotenuse. So all that's left is that this side has to be the long side. And again, that's 60, so since it's the bigger angle, it's going to be across from the longer side. This one has three different formulas that we can think of. If you want your short side, you can do the long side divided by square root of 3 or hypotenuse divided by 2. You don't have to do both, it's one or the other. But once you have the short side, it's a lot easier to find the other two sides by multiplying by one of these numbers. Okay, so we're going to do the odd ones again in this section. Number 7, find the values of x and y. So this is a 45, 45, 90 because I see that 45 degrees here. Across from the right angle is always the hypotenuse, which means that the other two are legs, and they're always equal. So if the right side leg is 5, then x has to be also 5. Okay, so we have at least one of our numbers. And then to find our hypotenuse, I'm going to go back to our notes here. It's leg times the square root of 2. Our leg was 5, so for y, 5 square root 2. That's it. This one was a pretty easy one. Okay, now turn to the back. Oops. Let's do it together. Find the values of x and y. This time it's the 30, 60, 90. Okay, so always across from the right angle is the hypotenuse. Here's our 30 degrees. So if this is a 30, 60, 90, 30 is the smallest side, so it needs to be across from the shortest side. So that's going to be short, and this is going to be long. Okay, so it's always easiest to find the short side first. So to find our short side, back to our notes, we can either do the long side divided by square root of 3 or hypotenuse divided by 2. But we have the long side in our problem, so we're going to use this one. Long divided by square root of 3. Okay, so x is our short side. We're going to do 42 divided by square root of 3. Only when you're dividing by radical, you're not allowed to leave it like that, so we're going to multiply by square root of 3 over square root of 3. So that turns this into 42 square root 3. Since one isn't alone and then one side inside the radical, you just write them next to each other. But these are both inside the radical, so essentially all that happens is that radical cancels out, and we'll get a regular 3 at the bottom. Okay, but now we try to simplify as much as we can. This is the only thing that has the radical, so that's going to stay alone, but these two are just normal numbers. Is 42 divided by 3 a whole number? So you should always check that. 42 divided by 3. And yes, it's 14. So for my final answer for x, I would say that that's 14 square root of 3. Okay, and then now I still need to find y. Y is the hypotenuse. So back to our notes. The hypotenuse is just the short side times 2. Okay, so for y, our short side we just figured out is 14 square root of 3. We're going to times that by 2. This is the only thing that has a radical, so that stays alone. But we need to multiply the regular numbers. 14 times 2 gives me 28. So 28 square root 3. So those are special right triangles. I know for these there is a lot of rules to remember, but again, you don't have to remember them. I'm letting you use all of your notes plus this review. So even if you don't have any of your notes and you only have this review, everything you need is on here. Okay, last topic was geometric mean. So either you're going to have similar triangles where these are the formulas, or they might just give you two numbers. So let's go straight into these. Number 11, find the geometric mean of 5 and 16. We're just going to do this formula. So square root of 5 times 16. Okay, well now I'm going to figure out what 5 times 16 even is. That's 80. And then we need to simplify this radical, so I'm going to factor this, menu to 3, type in my 80, and I get 2 to the 4th times 5. So that means that there's 4 2's, right? 2 to the 4th power, and then times 5. Okay, so we're looking for pairs. Here's a pair of 2's, and then another pair of 2's, and then the 5 is alone. So when you write this, you only write the number once for each pair. So 2 times 2 gives me 4. Then that 5 was all alone, so that's going to stay in the inside. 4 square root 5. And one way you can check this is by putting it in the calculator and checking to see if you get the same decimal. So we had did square root of 5 times 16. That gives me this. And then now my final answer, 4 times the square root of 5, gives me the same exact thing. So that's one way to check to see if you did it right. Okay, then for the next two, they're similar triangles. So I'm going to go back to this because I didn't really read it before. There's two different things that you can do with this. Geometric mean altitude. Altitude is always on the inside. So if that strip on the inside has a number or a letter, you're going to use this formula. E squared equals C times D. So altitude squared equals the two pieces of the hypotenuse multiplied. Okay, so say you don't have that. We also have geometric mean leg. So for geometric mean leg, so something like here, A is a leg. You'll do leg squared equals C. So that's the part of the hypotenuse that it's next to, times C plus D, the entire hypotenuse. So it kind of just depends on what you are given. Okay, so now let's look at our problem. Number 13. As soon as I see that inside has a label, so it's labeled as X, this is geometric mean altitude. I'm going to write it right here, GM altitude. So that one says you get the altitude squared, so x squared equals the two pieces of the hypotenuse being multiplied, so 20 times 9. So x squared equals, that is 180. We're going to want to take the square root of both sides, so x equals square root of 180, and simplify as much as you can. So I'm going to use my calculator to find those factors. Menu 2, 3, 180. So 2 to the second, 3 to the second, 5. So that means that there's 2 2's, 2 3's, and 1 5. So anything that's a pair can go on the outside. We're going to multiply. 2 times 3 is 6. And then that 5 stays on the inside. So final answer is x is 6 square root 5. Okay, but this first thing is always altitude. I bring that up because on this second one, this is our altitude right here. So you're going to start with 14 squared, and then I'll let you finish on that on your own. Okay, second one, inside is the altitude that doesn't have a label. So next thing I would check for is leg, which, yeah, see that 18? That's a leg. So geometric mean leg theorem. So it always starts with the leg squared. So 18 squared equals the product of two things. I'm going to go back to my notes really quickly. So when you have leg squared, and I'm just looking at this first one, it's a squared, so you would square that one, equals c times c plus d. So the piece of the hypotenuse it's touching times the entire hypotenuse. Okay. So the piece that it's touching, easy to see, is the 15. But then I need this whole piece added together. Well, x is not a number, so you can't really add it the way you normally would add numbers. But, I mean, we could still add two terms, right? 15 plus x. So times 15 plus x. 18 squared gives me 324. Then here we're going to need to distribute. 15 times 15 is 225. And then 15 times x is 15x. Let's subtract the 225 from both sides. That gives me 99. And then we're going to divide by 15. So this one is not going to be a radical. It's going to be just a decimal. Let's see. 99 divided by 15. I'm going to do Control Enter. That way I can get a decimal. 6.6. So that piece there is 6.6. Okay, and then that's all we need for geometric mean. Out of the whole test, I do think that these will probably be the hardest questions because you have to be able to recognize what pieces you needed. But you're allowed to use your review, so make sure that you are looking at these notes. Don't lose this review. Okay, and that's it. If you have any questions, let me know.